My dear students and learners, welcome to my 9th video of Engineering Thermodynamics, Unit 1, and this is regarding thermodynamic heat. Heat and specifically thermodynamic heat. What is this? Okay. So many times I told about the importance of the heat energy given by the sun, which is called solar energy, is the driving force for the whole universe. That too, this heat energy is so important, and it could able to move the things by its energy. That is, heat is energizing the various sources or the molecules present in any of the substances. Okay. Even I have given so many examples that how heat is acting in our body, what was the various effect of the heats, how it makes the molecules to move, or it migrates from one place to another place, so that the phase change occurs because of this heat. Everything was discussed already, right? Okay. So here, in subject point of view, some more added versions or features of heat is going to be discussed in this video. Heat is a form of the energy. Heat is the energy. Temperature is the measuring unit. Okay, measuring unit of heat energy, and heat is the form of energy being transferred without any mass transfer due to the difference in temperature. As already in the last video I told about, work transfer means except the change in temperature, any other properties changed means then it is considered as a work, but heat is considered as transferred if the temperature difference exists between inside the system or system and the surroundings. Okay, so heat always flow from higher temperature to lower temperature. This you would have studied in your schooling, and you can test this with various small testings or practical things in your home. Okay, sign conversions, as already we have seen that when work is taken into the system, it is negative, coming out means then it is positive. The vice versa or the opposite version is taken place in heat. When heat is taken by the system, or heat flow into the system is taken as positive, and heat flow out of the system is negative. Okay, because you want to utilize the heat energy, and if the heat energy is being inside the system only, you can convert that heat into work, right? So it has to be inside the system, then only it is advantageous for us. Okay, so when the heat is leaving the system or heat flow out of the system, okay, means it is considered as negative, and heat flow into the system is taken as positive. Whatever depending upon the purpose, if you realize the purpose of this subject, you can able to memorize or understood why this positive and negative signs has been fixed. Heat transfer due to temperature difference. Okay, as already told, always the heat energy flows from higher temperature to lower temperature, and opposite or reverse direction of this process could not be achieved without the aid of any external source or external work. Okay, that is, you can without any complications or difficulties, heat spontaneously will move or will flow from hot source to cold source. Okay, reverse direction from cold to hot region transfer is not at all possible. And how much amount of heat is being transferred from one source to another source, which are separated from temperature potential means mCp dt. The amount of heat transferred from hot region to cold region is equal to heat transferred is equal to Cp or Cv, means his specific heat of that substance into mass of the substance, how much amount of substance you are taking, ice, water, air, any gas, any refrigerant, anything, and specific heat of that substance into temperature difference between the two regions or two objects. Okay, this product of these things will be given you the heat transfer. And comparison, similarities between heat and work is both are path functions, they are boundary phenomena, they are inexact differentials, they are not the property of the system, they could not possessed or saved in the or stored in the system. They are all boundary phenomena, both are boundary phenomena and unable to store. In this manner, these aspects, they are matching with each other, and they also have the dissimilarities or difference of opinion in heat is considered as or called as low grade energy, whereas work is called high grade energy. This soon you can understand why I am telling like this. Okay, heat is low grade energy, work is high grade energy, and work needs unstable system. Unstable means if work cannot be entered into the system if it is stable. If it is stable, work cannot enter into the system. Like okay, let me explain this relation between this heat and the work. As a first example, you can say that when two persons are having the conversation with each other, okay, the effect of that talking, okay, will remain ever in their mind, but the conversation will come to end after they stop talking with each other, right? Like that, even though this heat and energies, they are coming in and going out in some other forms from the system or out of the system or get into the system, okay, their effect would be forever, but they will not be remain in its place in that system. Okay, the effect of their incoming and outgoing of these guests would be there in the system, but they will not present. The conversation will not takes place, but the effect would be always there. Like another one more example. In clouds, the water is saved as a water vapor. In lake, the water is saved and we are calling it as lake water. And in between the movement from the cloud to the lake, we are calling the same thing water which is coming or pouring down from the cloud is called rain. We are giving so many names depending upon the place where it has stored and in what form it is there. Clouds it is in as water vapor. During the rain it is called rain. After it has been reaching the lake, we are not calling it as rain, we are just calling as we are naming as water, right? Okay, like that, when work during the entering into the system, we are calling it as by some other name, and after it has been that is interlinked with the various sources of the system, it has converted to some other useful form, and when it leaves the system, both heat and work, when it leaves the system, the totally different form is being received by us, which is useful to us. Okay, so same work, same heat, but different, we are looking those things in the different views. Okay, Path function and point functions are already explained. Path functions are very specific. We can tell that the cyclic integral of any variable is not equal to 0, means then the variable is said to be a path function. Heat and work are path functions. They are only following the path in which that particular process takes place. They don't mind about the end states. End state, there is no particular end state for them. Instead, you can tell the difference between the two states, between that particular states, what was happened to work, what was happened to heat. Okay, point function means all the properties of the system would be considered as point functions. Exact differential means dv, you can write v2, what is v1, what is p1, what is p2, what is the value of that property at a particular state. Like the w1 or h1 cannot be written, instead h1 to 2, w1 to 2, like that. Heat and work are path functions, and other properties are point functions. Here from this it is very clear that both heat and work are not the property of the system. Instead, all other here physical variables are properties of the system. Then we will move to the important topic, or highlight, or hero of thermodynamics is first law of thermodynamics. Okay, here this first law of thermodynamics, already you have studied about zeroth law of thermodynamics. That is having some other sort of importance in such a way that it is used to measure the temperature of any bodies by having a permanent or fundamental datum is fixed. Like that, here first law of thermodynamics is having in its own important scopes and applications. Here this first law can be defined for any process, and second thing for a cyclic process or any cycle. Okay, process is different from cycle, you know very well. Process is change of state, cycle is change of state ending with the same initial condition, returned back to its original condition. Okay, so separately we will study about the first law of thermodynamics for any process, and then for cyclic process. Okay, for a cycle, okay, it is so interesting that in your schooling lower classes also itself you have studied about law of conservation of energy. That is, the energy can be converted from one form from another form, but it cannot be created or destroyed, not destroyed. Okay, under any circumference. This you would have studied. What is the meaning of this one is, whatever the resources available in the universe can be or could be converted to some other form which is useful to us. We can convert the form, but instead, however, we cannot create anything without the source given by the God. I'm not taking anything from this world, but I'm creating this. Okay, can you say like that? No, it is not at all possible. So you cannot create without the usage of any input source, right? Okay. A process is said to be cyclic if the initial and final state executing the process are identical. You know very well. Okay, so when this law is applicable to a cyclic process, you can able to see here cyclic process. Okay, cyclic integral of del q is equal to cyclic integral of del w. That is, cyclic integral of heat transferred is equal to cyclic integral of work transferred. Whatever the in various processes you have given the work input will be equal to or coming out as cyclic integral or addition of the work transferred